Hello, you're on the Space Daily News channel. On Thursday, May 5th, mission controllers at NASA Jet Propulsion Laboratory received confirmation that the agency Ingenuity Mars helicopter had re-established communications with the Perseverance rover. Early in the week, the rotorcraft had missed a planned communication session with the rover for the first time in over a year of operations on the Mars surface. Ingenuity relies on Perseverance at the base station that enables it to send data to and receive commands from Earth. While more data, downlinks and analysis are needed, the Ingenuity and Perseverance teams believed they have determined the cause of the anomaly as well as plan to return to normal operations. Data downlinked indicates that the communication dropout on May 3rd of the Perseverance rover's mission at Mars was a result of the solar-powered helicopter entering a low-power state, potentially due to the seasonal increase in the amount of dust in the Martian atmosphere and low temperatures as winter approaches. The dust diminishes the amount of sunlight hitting the solar array, reducing Ingenuity's ability to recharge its 6 lithium-ion batteries. When the battery pack's state of charge dropped below a lower limit, the helicopter's programmable array was powered down. This array manages Ingenuity's operational state, switching the other avionics elements on and off as needed to maximize power conservation. It also operates the heaters that enable the helicopter to survive frigid Martian night, maintains precise spacecraft time, and controls when the helicopter is scheduled to wake up for communication sessions with Perseverance. When this array lost power during the Martian night, the helicopter's onboard clock reset, and Ingenuity's heaters, so vital to keeping electronics and other components within operational temperatures, turned off. When the sun rose the next morning and the solar array began to charge the batteries, the helicopter's clock was no longer in sync with the clock aboard the rover. Essentially, when Ingenuity thought it was time to contact Perseverance, the rover's base station wasn't listening. To make sure Perseverance would hear a call, Perseverance mission controllers commanded the rover to spend almost all of day on May 5th listening the helicopter's signal. It came at 11:45 a.m. local Mars time. The data transmitted was limited, but the helicopter's critical health and safety data was nominal. The radio link between Ingenuity and Perseverance was stable. Spacecraft temperatures were within expectation. The solar array was recharging the battery at a rate expected for this season, and the battery was healthy, containing 41% of a full charge. But one radio communication session doesn't mean Ingenuity is out of the woods. The increased dust in the air means charging the helicopter batteries to a level that will allow important components to remain energized throughout the night presents a significant challenge. Each night for the past 3 sols, Ingenuity's heaters have kicked in when its battery temperature was below 5 degrees Fahrenheit. But the team believed that the battery couldn't sustain the energy draw of the onboard heaters throughout the night. The Ingenuity and Perseverance teams have designed a plan they hope will make a difference. Their goal is to help the helicopter's battery accumulate enough of a charge during the next few sols, so that it could support all necessary spacecraft systems during the cold Martian night. Uplinked yesterday, the new commands lower the point at which the helicopter energizes its heaters from when the battery falls below 5 degrees Fahrenheit to minus 40 degrees Fahrenheit. The helicopter then shuts down quickly, rather than consuming the battery charge with the heaters. The team hopes the strategy will allow the battery to retain whatever charge it collected during the day. The Ingenuity engineers hope that after several days the battery will have reached a point where the spacecraft can return to normal operations. Ingenuity became the first powered aircraft to operate on another world. For that moment, the rotorcraft has flown over 4.2 miles across 28 searches and operated from the surface of the Red Planet for over a year. This was Space Daily News with Julia. Stay tuned.